Ladies and gentlemen, welcome to my presentation. At first, I would like to introduce myself. I am MD Sharif Hossain, Assistant Professor, Department of Information and Communication Technology, Kumila University, Bangladesh. Today, I will talk about implementation of encryption techniques in secure communication model. In this presentation, at first, I will talk about introduction. After that, encryption techniques, then proposed approach. After that, result and discussion. Then conclusion and future work. Now, introduction. In this modern world, data security is a prime concern in any communication. Third parties are trying to steal credential information like password, credit card details, etc. That's why different encryption techniques are used to prevent attackers by making the masses human unreadable. Two types of encryption techniques are used. The first is symmetric, where a single private key is used. The other is asymmetric, where both private and public keys are used. The most common example of symmetric encryption are Caesar, DES, RC4, Triple DS, Bloffies, and RC6. The examples of asymmetric encryption are RSA, DSA, Diffie-Hellman, etc. Figure 1 shows the basic concept of symmetric encryption. And here, at first the plain text is encrypted using RSA algorithm and secret key, where the encrypted version is called the ciphertext, which is passed through the media. This ciphertext is then decrypted using a decryption algorithm and a shared secret key. Then we will get the output text. So this is the concept of the symmetric encryption. Now we will talk about asymmetric encryption. Here we consider that Bob wants to send a message to Alice. And here Bob at first encrypts the plain text using Alice's public key and the RSA encryption technique. Then we will get the ciphertext. This ciphertext is then decrypted using the decryption algorithm and Alice's private key. Then we'll get the original plain text. So this is the concept of the asymmetric encryption. Now we'll talk about encryption techniques. In this research investigation, we have used Caesar and RSA encryption techniques. Caesar cipher. Here, every letter in the plain text is shifted down or up according to the user's demand. With 3 shifts of plain text, we get the ciphertext. Say for example here, the plain text is meet me after the toga party, and the ciphertext is PH, WPH, etc. In this case, we consider that M corresponds to the number 12, and after 3 shifts, the number will be 15, and 15 corresponds to the letter P. So M is replaced by P. Repeating this process, we get the complete ciphertext. Let us consider that C, P, and K indicates the ciphertext, plaintext, and shift of character. Then the ciphertext can be obtained by the first equation, C equals to P plus K mod 26. And the plaintext is recovered from the ciphertext using this equation. That means P equals to C minus K mod 26. Now we'll talk about RSA. Figure 3 shows the procedure of RSA algorithm. Here you consider that Bob wants to send a message to Alice. And in this case, we have to calculate the public and private key at first. Let us consider that P and Q both are prime numbers. And here we have to calculate n equals to P multiplied by Q. And then phi of n equals to P minus 1 multiplied by Q minus 1. Then we'll choose E, where the value of E will be greater than 1 and less than phi of n. Then we will calculate D. D equals to E inverse mod phi of n. And here the public and private key. Now Bob uses the Alice public key to encrypt the masses. So this is the ciphertext. And then Alice uses his private key to get the plain text from the ciphertext. That means M equals to C to the power T mod n. Let us consider an example of RSA encryption. And here we consider that the plain text is 88. And in this case, RSA encryption technique encrypts this plain text using the public key 7. Then we will get the ciphertext 11. Then this ciphertext is decrypted using RSA decryption algorithm using the private key 23. So we will get the plain text 88. So this is the concept of RSA encryption. Now we will talk about proposed approach. To ensure the data security in the communication model, we have proposed and implemented a model. The model consists of two parts, transmitter and receiver. In the transmitter part, at first the plain text is encrypted using RSA encryption technique. And then the encrypted version is modulated, which is then passed through the channel. In the receiver side, the channel output is demodulated and decrypted to get the original plain text. So this is the concept of our proposed model. Now we'll talk about result discussion. In this research investigation, we have used two encryption techniques, RSA and Caesar cipher. The performance of RSA and Caesar cipher have been shown using BER versus SNF plot. In this investigation, we have shown the compression of no encryption with Caesar cipher, compression of no encryption with RSA, compression of RSA with Caesar cipher, and finally we have shown the combined compression of no encryption, Caesar, and RSA. Figure 6 represents the compression of no encryption with Caesar cipher. And here we see that with the increase of signal to noise ratio, bit ratio is gradually decreasing. And here we observe that the bit ratio of Caesar cipher is lower than no encryption. Figure 7 shows the compression of no encryption with RSA. And here we observe that bit ratio of RSA is lower than no encryption. Figure 8 represents the compression of RSA with Caesar cipher. And here again we see that RSA encryption technique ensures lower bit ratio than Caesar cipher. Figure 9 shows the compression of no encryption RSA and Caesar cipher. And here we observe that RSA achieves the better performance compared to other approaches because it ensures lower bit ratio among no encryption and Caesar cipher. Now, conclusion and future work. Actually, data security is very important in the communication between two parties. To ensure the data security, we have proposed and implemented a communication model. In the proposed model, we have compared the performance among no encryption, Caesar cipher, and RSA encryption techniques. And here we observe that RSA deserves the better performance among the three methods because it ensures lower bit ratio. In near future, we would like to extend our work by comparing the performance of other encryption techniques, that is DES, 3DS, AES, etc. Moreover, we would like to propose a new encryption technique which will outperform the other approaches. References. Here are the list of references that we have used in our research paper. Thank you. Any question?